When there's new product comes out, are you more like excited or depressed? It can be a new car model, new device, new computer. I'd feel excited. But here's the thing, nowadays AI and GPU stuff is evolving at almost like a speed of light. However, robotics frameworks have been kind of staying there pretty much the same. And recently ROS 2 came out, Xeno came out, and today meet Dora-rs, a fresh take on robotics with a completely different philosophy than ROS. It's still experimental, but here's what's fascinating: how this 1 millisecond AI, the group who released this, is taking a totally new perspective and approach. Unlike the traditional message passing system, including ROS, and then a couple of weeks ago I talked about RabbitMQ, ZeroMQ, like other message delivery system for publisher-subscriber pattern. However, Dora-rs do not use any of those. It just does it totally differently. So today, let's break it down. And if you're new to here, my name is Elliot. I'm a robotics engineer, educator, and my mission is to help people land on the field of robotics as smooth as possible. First, I'm going to talk about what they are, and I'm going to talk about one of the examples they provided, and let me go through that with you. So let's get started. So what the heck is Dora/rs.ai? It's just another robotics framework just like ROS, but I'm quite excited about it, although it is experimental, because the philosophy and the perspective of this framework is totally different than ROS or any other message passing system like RabbitMQ or ZeroMQ like I talked about in the last video. Especially I like their first statement. In 2024, AI is booming. Robotics framework, however, hasn't changed much in years. This is why we created Dora-rs. Dora-rs is a new robotic framework that brings modernity into robotic application. That's such a strong statement and brave, and I like it. So Dora-rs is actually not based on any of the networking system. Instead, it's based on Apache Arrow. What's the Apache Arrow? Apache Arrow is a data format framework for your shared memory. Actually, I didn't even know, honestly saying, and I think it's interesting. It's been almost like a 10-year out there. It came out like 2016. And I never thought about it because whenever I try to program the shared memory stuff between the two different applications, I always get like the blue screen of the death, or my operating system always just abruptly reboots. So I almost have a trauma about the shared memory programming. But with this, it's much robust because they provide more like a memory format for your data. This is the backbone of Dora-rs. It's not passing any messages, instead it's just relying on the shared memory. That's why it's really fast. So if I actually look at their performance, if I zoom in a little bit, so when it comes to CPU, shared memory is freaking fast. When it comes to this much megabytes, ROS is really slow. I mean, if you're actually publishing the image as a data before processing images, and there is like significant amount of delay that you can even notice. However, it's based on the shared memory, so you don't even have to copy the data and send the data over the network. Instead, when it comes to image processing, you are just passing the pointer to the image location on your computer, then another application can literally grab that image data from that application. That's why I believe the latency is really low like that. And then C and C++ is, I think they are most same. Yeah, that's astounding. And then another thing that is really interesting is that they also provide PyTorch CUDA-based shared memory. I think that's really new idea to me. I never even thought about sharing the memory through the GPU. I mean CUDA. So this is really interesting result, I think. And I know ROS has been there a long time, and a lot of people are still using ROS. And I know there are diverse opinions, but still, I want to give a positive feedback to these people, this project, because they bravely took the new approach and they especially made it for free. So I salute to them. I don't want to give any negative feedback because I don't need it, or I don't really use it for my real use case for my product and so on. But rather, I really want to keep monitoring this project, then keep trying out new packages and so on. And then when it comes to actual system, they not only come with different languages, but also they support, obviously, ARM. I think they have tried with the Jetson series as well, the NVIDIA Jetson I'm talking about. So that computer is based on ARM architecture. So obviously, I'm pretty sure they are aware of CPU architecture as well. Now I am on their GitHub page, and it just looks like that, and they are advertising that Dora is much faster than ROS2 in Python and Rust. I think they have about same performance with the C++. But anyways, I think it's really interesting, not because their performance itself, but their different idea of the approach. And then another interesting perspective of this Dora is this YAML file. At least I think it's interesting. I know people have different opinions about different frameworks. I'll listen to it. Please comment down below. But at least I'm saying that this is my personal opinion because I'm a freaking random YouTuber. Am I? If you haven't subscribed my channel, please subscribe the channel and please hit the like button right now. Please. Anyways, I think this is interesting. What they are doing with this YAML file is that they define each node like ID and then build and then pass to the application. And then they define the inputs and output data. And then the later nodes are depending on one of these outputs from the earlier node and so on. And the reason why I think it's interesting is because I kind of remember this old memory of the MATLAB and Simulink. When it comes to Simulink, I like the Simulink before because I can just intuitively draw this control flow, and then I just literally drag and drop the arrow from one node to another node, and then double click that node, and I can just literally write the code, like control algorithm code in MATLAB. And that kind of works together. I think that's fantastic, except that they are expensive software, so I'm not using them. But maybe with this kind of YAML design, maybe that kind of Simulink-like UI may be possible in the future. I don't know. So this is an interesting project, and especially it's because of the experimental level. It has a lot of potentials in the future, so I am excited about this. So currently I'm recording this on Windows, and I just downloaded this GitHub, and I try to run this on VS Code, and as you can see, I feel like the Windows version is not really building well, although I have running Rust C and Python, and I just followed all these, it doesn't work. So let me turn off this now and then try this in Ubuntu just to see, and also I'm not using WSL because this example requires a webcam, and then if I try to attach my webcam to WSL using IPD, it just kind of doesn't work well. I don't know why. Anyways, I will record it in Ubuntu and then I'll get back to you. Okay, obviously I couldn't even record the video while I'm doing the screen video in Ubuntu with my mic together, so I just recorded my screenshot from the Ubuntu and I'm back on my Windows again. So let's watch this clip together. So that's the same GitHub, just build and then running, and build and running, it's just a couple lines of code. They made the README file really neat, so I didn't have to do anything else. And then if you run this, they are using this rerun.io as a data visualization. And then actually I like it too, because rerun.io looks more modern than RVs or RQT. And then this UI is really important when it comes to packaging stuff, right? Because I always buy the fancier box and then I regret all the time. I mean, the UI, my point is the UI is one of the reasons to attract more people, right? So I think that's also a good strategy, because they don't have to keep reinventing the new things for their own framework, right? So they can just adapt to rerun.io as well. So what I'm doing here is YOLO running, and then after YOLO, these bounding boxes here, I can't see here. Not sure if you can see this, but here, after all this YOLO, it's just sharing the data as bbox, right? The YOLO bounding box. And then another application can just grab this data and then publish to rerun.io. So they are testing out their data flow. And then this is just a YOLO algorithm that's working. So I hold a book and it says a book or refrigerator or something like that. But anyway, that's YOLO. Anyways, so I think this approach is really interesting to share the memory with applications. And a very important thing, they are actually relying on Xeno for the device-to-device communication. So somehow they got this shared memory table, and then there must be some kind of publisher to the Xeno router. They are able to communicate with different devices. And if you actually go to their website, you can also find a lot of examples, and they also have examples for ROS as well, and ROS2 bridge as well. So you can always mix with ROS, which is very good. And especially, I think they are quite happy because one of the person from Hugging Face was using this tool to test out their first robot model. So check out that history as well. But anyways, I think that's it. I think it's a really interesting project that we might want to keep monitoring, because we don't want to fall behind. You don't have to adapt to this new tool, or maybe you can still stay in ROS. I don't know who's gonna be winner, or will there be any winner at all? I don't want to see the word as like superior inferiority and that kind of fight. Instead, I think we customers, we users can have more diverse tools that we can just use whatever is best for us, right? So we don't want our project to be dictated by the tools that we have. Instead, we want the best project based on whatever tools are available for that specific project. So I think this diversifying robotics framework is really an interesting movement, and I support it. Actually, it's not new. It's been a couple of years out there, and honestly, I didn't know until like a couple of months ago. So I wanted to talk about it. So I recommend that you check out and let me know how you think. And their talks are really interesting. So I also recommend check out their videos as well. And I'm also glad that it's just not my own opinion that the ROS and ROS2 experience with the complex build system. It's not just me. I'm glad to see that I'm not alone. And my last point is that, like always, if you're curious about how to get into the field of robotics, please check out the link down in the comment section. I have a robotics 101 course, so check out that too. And don't forget to like it and subscribe my channel. Thank you for watching. This is Elliot. I'll see you around.